Hello, everyone. We appreciate that you all have taken the time to join us today. My name is Rakesh, and I have the pleasure of being the host for our second webinar in the series, AskADetoXpert. The objective for today's session are twofold. The first one is to look deeper into wastewater reports with regards to MRSL parameters and see how they vary by country and by production processes. And secondly, is to get a glimpse into using existing knowledge for conducting root cause analysis, and we'll see this with a few interesting case studies. Also, in order for you to engage with us, you'll see buttons or widgets around the screen, which you can use for typing your questions and also for sharing your comments. As we start off, let's have a short look at our fellow participants today. With the chart on the left, we see that we have representation from various stakeholders from the industry. Along with brands and retailers, we also have representatives from both the Tier 1 and Tier 2 manufacturers that, of course, need to do all the hard work for eliminating the harmful chemicals. It's also useful to see participants from industry associations, from international donors, and also our peers from testing and certification. On the right-hand side, we see that we have the privilege of having participants from several regions today. So, ni hao, namaste, xin chao, salam, merhaba, bonjour, and of course, guten morgen. Next up, let's look at the current situation in the factories. On the left, we see that over half of the respondents mention that less than a quarter of their chemical inventory is ZDHC MRSL compliant. It will be interesting to compare this with the ZDHC in-check reports on the gateway. On the right-hand side, we see that chemical groups like APEOs and heavy metals continue to be a challenge to eliminate. To take us through today's session, we have Ms. Aro Xu. She heads our team for chemical management audits and verifications in Greater China. This team is also involved with RCA activities and works on capacity development projects with development organizations such as GIZ to support factories of German brands and retailers in improving their chemical and environmental performance. Next up, we have Mr. Shivendra Parmar. He's our technical manager in India. Shivendra holds a master's degree in textile technology. He has over 14 years of experience in the industry. Prior to joining to Rhineland, Shivendra was involved in academia as assistant professor in Textile Engineering College. He's also a ZDHC trainer and is hands-on, including activities that involve test method development in the chemical lab for international standards and regulations. Additionally, Ms. Evelyn Pai will also be available during the Q&A session. She's our specialist in chemical data analysis, and myself, Rakesh, based in Hong Kong. We'll go through today's webinar in 3 sections. Let's start off looking at the big picture about the major motivations for the textile industry to address harmful chemicals in products and in wastewater discharge, and to answer the all-important question, why? For getting to know the why, it's useful to take a look back in the past. We see that even before the start of Greenpeace's detox campaign, there were reports indicating pollution being caused from electronics and textile industry, adversely impacting water and aquatic life. The overall focus of these reports can be broadly categorized as highlighting the hazardous chemicals in finished products such as garment and also in the effluent discharge. Along with Greenpeace, we also saw the NGO IPE in China stepping up efforts highlighting similar issues. Finally, we also saw reports about harmful chemicals in samples of snow, indicating that the water and oil repellency of our jackets was having an adverse environmental impact. This led to updates for the product safety and quality requirements via the RSLs and to the supplier code of conduct that now started to include stricter requirements for monitoring emissions. This, is represented with the new approach for chemical management, or rather chemical compliance, whereby in addition to the RSL requirements for finished products, there is also emphasis on production process and on the input chemistry, which is governed by the MRSL. Now, while NGOs were surely a constructive stakeholder, companies, especially the brands and retailers, also had to address the requirements of their wider stakeholders. That includes investors, stock exchanges, and of course, the future generations. As an example, we see that non-financial reporting includes criteria for managing chemicals in both the products and the supply chain based on industry standards such as ZDHC and SAC-HIG. With regards to the companies involved, we are talking about many of your favorite brands and retailers who have joined forces with global industry programs like the ZDHC, SAC, AMFORI, and the German Textile Alliance. Let's look at the current situation in terms of wastewater quality. Taking example of China, thanks to the great work of IPE team. In this example, we see with the dark colored areas, especially along the coast and also inland, that there's still need for improvement. We see similar results looking at the Detox Live platform, along with the red dots that indicate presence of harmful substances from the wastewater discharges in Asia. We also see a lot of reds in Europe. This is exactly where the complete set of standards and guidelines for wastewater analysis, MRSL compliance, and the Supplier to Zero program can be useful to have a stepwise approach towards the goal. Now, having looked at the why question, let's look at the what. What are some of these harmful chemical substances that we are talking about, and where are they typically used during textile production? For this, my colleague Mr. Shivendra Parmar will share further insights based on what our labs have experienced, together with the data analysis work that was performed by Evelyn.
Thank you, Rakesh. Hello, everyone. Welcome to this webinar from my side too. Here's a graphic that many of you would have come across. It is a part of ZDHC impact report, which indicate that while there has been progress made on elimination of several harmful chemicals, there are few chemical groups that require more work. We see from these examples that APO, halogenated solvents, PFC are among the ones that are still detected in wastewater reports. Now, let's take a closer look. In order to support factories, we conduct regular data analysis of test results. What we observe is that while APO are still detected for 1 out of 10 results, there are also prevalence of PFCs, phthalates, halogenated solvents, and others also. But as we know, the usage of chemicals varies significantly from factory to factory, especially based on the production process. It could also vary by quality of local chemical supply, the ETP setup, etc. SSCP detected in incoming waters in factory located in Shanghai, Xinjiang, and when we are talking about PFC detected in incoming water in factory located in Qingdao, Shaoxing, Hangzhou, and when we are talking about organotin compound detected in incoming waters in factory located in Hangzhou, and there are some phthalates detected in sludge from reports from China and Vietnam in some factories in China located in Qingdao, Linhe, Hangzhou, Shaoxing, etc. When we compare factories in different countries with on-site ETP and central ETP, based on the graphical presentation of different 5 countries, it shows India, Bangladesh having more on-site ETP facility as compared to central ETP facility, and Vietnam, China, and Turkey is having more central ETP facility as compared to on-site ETP facility. When we do test result analysis based on process type as per finding of incoming water, raw wastewater, discharge wastewater, and sludge, it was found that halogenated solvent presence in different processes like dyeing, printing, finishing, washing. When we talk about VOC, it is found in printing, dyeing, finishing. When we are talking about PFC, it is found in tanning. When we are talking about heavy metals, it is found in dyeing, printing, finishing, washing. It will be very useful to revisit this data once the supplier profile on ZDHC gateway has been completed. We might get further insight based on the type of fiber processed. When we are talking about chemical group detected in different countries based on the test result and based on the process type in different countries, it is found that when we are comparing different countries like India, it is found that AP chlorophenol detection in waste water only, heavy metals detection in incoming water, wastewater or sludge. When coming to the another countries, China, AP found in sludge only, and when there's another chemical parameter, APO, it is found in wastewater and sludge. Then come to azo, incoming water and sludge or wastewater, it has been found. When we come to Turkey, chlorobenzene and toluene is found in wastewater. And talking about another chemical parameter, halogenated solvents, it is found in incoming water and sludge or wastewater. And then come to Vietnam, organotin compound PFC is found in wastewater and sludge only. And when we are talking about heavy metal, which is found in wastewater and sludge. Now, while factory setup efforts to implement better chemical management, wastewater test result is used as one of the tools to verify the effectiveness of the measures. While such tests are only a snapshot in time, the result can be useful for giving hints about aspects that need further improvement. Let's take an example to see how test report can be used to drive improvement. Here we see APOs being detected. The next step could be that the factory utilizes MRSL smart testing grid to look for chemical types that may contain APOs. Thereafter, check within the chemical inventory to understand if those chemicals are MRSL compliant and that they are being used as indicated in the safety data sheet and technical data sheet. Based on MRSL guidance sheet for textile and leather product auxiliaries, here we see the impact on chemical substance groups. Because if we see the MRSL testing grid, there are a lot of auxiliaries, finishing agents for fiber and yarns are there, pre-treatment agents are there, auxiliaries for dyeing and printings are there, finishing agents are there, pigments and dyes are there in these smart testing grid. So when we compare with the chemical substance, it is found that APO is found in 130 chemical, halogenated solvents are found in 100 chemicals, PFC is found in 14 chemicals, heavy metals are found in 93 chemicals. So this is the particular when we see the impact on chemical substance group as when we refer the MRSL guidance sheet. Based on further analysis of chemical use as a percentage of substrate weight for different processes like spin finish, weaving sizing, scouring and bleaching, dyeing, washing, finishing. Here in the particular table it has been mentioned the percentage of chemical used based on the percentage of substrate weight. Here we discuss about hazardous chemicals which are used in the textiles, their applications and their harmful effects. When we are talking about APOs, they are used as an emulsifying agent, detergent, weighting agent, even as a degumming agent for silk. They are having acute toxicity. When we are talking about formaldehyde, they are used as a easy care finish for dye fixation agent. And when we are talking about their formaldehyde harmful effect, they are carcinogenic, respiratory issues like that. When we are talking about phthalate, they are used as a softener, plasticizer, and they have harmful effect like CMR, carcinogenic, mutagenic, or reproductive related issues. And when we are talking about heavy metals, they are used in dyes and pigments. They have specific aquatic effects and toxicity issues. When we are talking about chlorinated solvents, they are used in adhesives, spot cleanings, and they are having carcinogenic, ozone, and issues related to the central nervous system. As many of you would know, both AFIRM and ZDHC have 1 to 2 page chemical information sheet that are freely downloadable. These have a summary about the harmful effect of various chemical groups where they are typically found in textile production, references to regulations where they are already restricted, and in many cases, references to substitutes. They are also available in several languages, so be useful for facility to initiate the root cause analysis also. If we talk about APU, it is one of the common problem in most of the industries. It is carcinogenic in nature. It is having high risk for aquatic animal and human being. It is sometimes mostly source is the incoming water also. When we are talking about the usage, industry laundering agent, emulsifier, dispersing agent for dyeing and prints also, even in spinning oils for yarn and fabrics, weighting agent, they are found in degumming agent for silk production, etc. And if you are interested in looking at the substitution methodology online via example US EPA or Subsport, etc., it is shown. You can refer in these particular slides. In this slide, we talk about perfluorinated and polyfluorinated chemicals, which are commonly used in textile or leather finishes for water, oil, or stain repellency, even in paper production, wood contact material. When we are talking about their hazardous characteristics, they are very persistent in the environment and have the potential to bioaccumulate in humans and other mammals. Also, for PFCs, there are a lot of activities going in terms of substitution. Here are some for your references. Here we talk about halogenated solvents. They are carcinogenic in nature, very toxic to aquatic life. They are used in plastic, printing, ink, paints, coating, adhesives, even in textile processing as a scouring solvent or a carrier solvent for preparation, and even in different types of functional finishes. They may also be used as a urethane foam, even as a blowing agents, chemical intermediates, and different types of dyes and pesticides, and sometimes used as an industrial cleaner for some processing equipments, boilers, etc., and even the spot cleaner also. There are a lot of activities are going on, and there are some sources available which there where you can find more information related to halogenated solvents. Here we discuss about another hazardous chemical, chloroalkanes. Here chlorinated paraffins, which we call as a short chain chlorinated paraffins, are a group of chemical substances used in leather industry due to their properties as a greasing product. Additionally, they are also used in a textile industry due to their fireproof and plasticizer properties in polymeric materials. And when we are talking about SSCP or short chain chlorinated paraffins, they are also classified as a persistent organic pollutant and very bioaccumulative substance. SSCP are toxic to aquatic organism at lower concentration and may cause long-term adverse effect in the aquatic environment at certain exposure level. Some basic details are available for your reference here itself. Thank you.
Thanks, Shivendra, for those insights and the explanation. And Evelyn, thanks for extracting the details from all the data. Now, having looked at the why and the what, let's see a bit into the how for the root cause analysis. For this, my colleague, Ms. Aro Shu, will share details along with a couple of case studies.
Thank you, Rakesh. Good morning and good afternoon, everyone. This is Aro speaking. Following by Shivendra's WasteWater report analysis and hazardous substance introduction, I would like to share with something about the root cause analysis, and its abbreviation is RCA. Firstly, I would like to ask, why should we start RCA? Who requires us to proceed RCA? Here we list some examples. like the ZDHC Foundation and the Partnership for Sustainable Textiles, who are calling for root cause analysis. A heat index. If you have conducted heat index FEM verification, you may know that it is also asking if factories conduct RCA and its wastewater section criteria. And besides, there are many brands have its requirements in their supply chain. Here we screenshot requirements of some brands. CNA requires its supply chain to identify the following chemical detection back to its original source and looking for alternatives. Text also conducted RCA work and issued a root cause analysis report in 2017, showing that 85% of non-compliance in RCA is coming from chemicals. And G-Star and Burberry are also require RCA. Of course, there are many other brands or organizations are also pushing us to do RCA work. Now, we go into the RCA logic. According to the law of conservation of matter, matter will not disappear for no reason. It will not happen for no reason. It's just a transition from one state from another. To know why the hazardous substance exists in the wastewater, we need to know firstly what substance enter into wastewater. If you are familiar with ZDHC, you may know that ZDHC monitors the discharge of hazardous substance in 3 stages: input, process, and output. In the ZDHC scope, currently, input means chemicals come into factories. Process means chemicals used in the factory. Output means chemicals discharged from factories in the wastewater and sludge. And now, I would like to use this concept as well as go deep into these 3 items. In this slide, I draw a general production process in a dyeing unit as an example. You can have a think about, besides the chemicals, if any other materials or sources are put into the unit. Energy like electricity, steam, water, raw material, and so on. You can find these resources in this slide highlighted in blue. And besides the wastewater and sludge, what else will be generated in your factory? Air emission, waste, empty buckets, which highlighted in yellow. Then you will get a chemical flow chart of your factory. In this way, you will easily identify how the chemicals are going in your factory, and as well as how do chemicals go into the wastewater. By using this chemical flow chart, you may also know well your NPO, that means non-production output, and if you can work further to reduce your cost. Using the methods in last slide, we could easily identify what potential resources have impact on wastewater in the production. And fresh water in some areas, especially when factories use surface water into production, restricted substance may be present in the fresh water because restricted substances are harder to degrade, which will also contribute to the presence of hazardous substance in discharged wastewater. WT chemicals, that means the chemicals used to treat fresh water. In dyeing industry, the hardness of water used in production should be monitored to ensure a good dyeing performance. So, chemicals will be needed to use to treat fresh water if the incoming water quality is not good as enough. Dye stuff and auxiliaries, it may be known by all of you. They are the main potential sources of hazardous substances. And testing chemicals. If factories have laboratories, chemicals used for testing may also have impact on wastewater, such as heavy metal, manganese, and chromium. And fabric. Here it means gray fabric. During the manufacturing of gray fabric from raw material, many catalysts, acid, alkaline, oil and grease, and so on are used, which maybe exist as residues in the gray fabric, and they go into the wastewater along with the dyeing process. And WWT chemicals means the wastewater treatment chemicals. The chemicals used to treat wastewater, and the heavy metals maybe exist in these chemicals. Last but not the least, don't forget the non-production chemicals like cleaning agents. They may also contribute to the detection of hazardous substance in the wastewater. We have already known the possible sources of hazardous substance in the wastewater. And then, what should we do to prepare for the RCA? We still use the concept of input, process, and output. In the output stage, we should read and analyze testing reports and determine if it is a certain event. If it is an accident event, then there will be very low chance to address the root cause. But if it is a certain event, then we can go to the next step. We need to know the main function of the detected hazardous substance. APO is working as a surface active agent. It may exist in softener, cleaning agents, and so on. Another example is PFC. And PFC is working as water and oil repellent agent. All this has been talked by Shivendra already. So if you have interested in them, you can go back to those slides after the webinar and visit the ZDHC or a foreign website to look for the targeted substance. And in the process stage, we should monitor and control the chemical use in the production process with the recipe and the production flow cards to ensure a good chemical traceability. If the factory has a good chemical traceability system, the range of the suspected chemicals will narrow down and RCA process will be accelerated. In input stage, it is a very, very, very important stage. It is the footstone of RCA work. Without the work in this stage, RCA will not be workable. So, in this stage, we should have a good chemical registration, chemical inventory, MRSL compliance level identification, raw material inventory, incoming water. I will talk more in following slides. And you can find that many works need to be done for RCA. It can be hardly done by a single person, but needs a team. So a professional chemical management team is preferred for RCA. Here, we give an organization chart of chemical management team. Top management should direct the whole factory to conduct chemical management work. The responsibility is to approve chemical management policy, to provide financial and manpower support, and to participate in regular chemical management meetings to monitor the chemical management process. And the chemical manager should lead the chemical management work in a whole facility. He or she is responsible for the chemical management task assignment and day-to-day chemical management work. Purchase department is to purchase chemicals to ensure purchased chemicals are in compliance with legal and client's requirements. Other departments like a production department and quality department should also join in the chemical management work and work for RCA. As a prerequisite, a good chemical inventory should be available for RCA. In this slide, we attached ZDHC chemical inventory template. If you have your own, that's fine, but suggested to include at least a chemical name, chemical supplier name, chemical manufacturer name, SDS in local language availability, ingredients, case number of each ingredient, MRSL compliance, chemical storage, and so on. In the chemical inventory, all chemicals used in non-production and production should be included. And the chemical inventory should be updated regularly to ensure all information are most updated. Another prerequisite is the MRSL compliance evaluation. We need to know the risks of used chemicals of containing hazardous substance. According to the ZDHC MRSL conformance guideline, MRSL conformance level is classified into 3 levels. Level 0 has been deleted from last version, MRSL 1.0. MRSL conformance level 1 requires a third-party review of documentation or an analytical test report where the data meet the quality assurance and quality control requirements in Annex A to be accepted as evidence of conformance. MRSL conformance level 2 requires a product stewardship, and level 3 requires a visit to manufacturer to assess the chemical management. Our chemicals users should evaluate the used chemicals against this criteria and determine the MRSL risk ranking of used chemicals. For a successful RCA, chemical traceability is also very important. Traceability means you can track used chemicals from final product, for example, a coat, to the chemical inventory, where the ingredients of chemicals, even low number of chemicals, are shown. A good chemical registration, process flow cards, and chemical recipe are the foundation of a good chemical traceability. A good practice is to have an ERP system to record each chemical usage in each order. RCA is a step-by-step process by narrowing down the range of suspected chemicals. We cannot identify hazardous chemicals by our own eyes. Instrumental analysis will be needed to address and confirm the problem. Here is the root cause analysis case we conducted for one factory in last year. Dichlorobenzene is detected in the wastewater at 50 ppb in the factory's testing report, and the incoming water is free of this substance. 300 chemicals in total were used in the factory. And after interview with the factory responsible person, found that dichlorobenzene was always tested in wastewater in the past years. So it is a certain event. As known that dichlorobenzene is usually used as intermediate during the composition of dispersed dyestuff. So the 50 dispersed dyestuff in the chemical inventory are most suspicious. And because the wastewater was sampled on July 15, so recipe and the production flow cards 3 days before the sampling date were reviewed and found only 30 dispersed dye stuff were used during that time. And with the review of SDS and MRSL compliance declaration and the testing reports, there are no MRSL compliance evidence for 6 dispersed chemicals. So these 6 dispersed dye stuffs are most suspicious. Till this step, we have no other documents or methods to narrowing down the range of suspected chemicals. Then we have these 6 dispersed dye stuffs tested, and 3 of them contain dichlorobenzene according to the testing reports. Another case is about the PFOA. PFOA was detected in wastewater in one factory at 10 ppb, while it was also detected in incoming water at 1 ppb. As the detected value in incoming water is much less than that in wastewater, so we believe that there must be other resources contributing to the presence of PFOA in wastewater. After interview with the factory responsible person, and found that it is also a certain event, as known that PFOA is usually used as the water and oil repellent agent. So only 3 water repellent chemicals are found in the chemical inventory. And chemical A and B are purchased by the factory itself, while chemical C is brought by the client to process the performance. With the review of SDS, MRSL compliance declaration, and found that 1 chemical contains C6, and 2 of the 3 chemicals have no SDS or MRSL compliance declaration. So we get chemical B and C tested, and found the C8 in exist in chemical C. By using this case study, I would like to remind you that chemicals brought by clients may have impact on wastewater as well. So the scope of chemical management should extend to chemicals brought by other persons. So we have talked much about RCA, and now let's begin to it. In ZDHC website, there is a companion tool for ZDHC wastewater guidelines, wastewater and slide root cause analysis and corrective action plan. You can visit the website and download this tool for the RCA work in your factory. That's all I would like to share about the root cause analysis. If you have any questions, we may talk further in the Q&A session.
Arrow. The case studies nicely highlighted the importance of managing chemical inventory and controlling the process. Here's a graphic that showcases our points of intervention, that is evaluating the input chemistry right at the beginning, validating the production process via an audit or wastewater analysis, along with root cause analysis via our impact program for improvement actions. And finally, assessment of the end product to make sure that it's safe for the consumer and also for the circular economy or the environment, depending on what happens at the end of its life. During our first webinar in the AskADetoXpert series, we had a chance to listen to our team members from Germany and Vietnam, that is Stefan and Dr. An. Today, we've heard Arrow and Shivendra. Now, based on your location, here are some additional contact points along with an overview of our services there. Here are some of the public resources that we utilize for compiling information for today's webinar. Now, while you all have been patiently listening, our colleagues Lain and Ryan have been sifting through the many questions that you all have raised. Let's go through them now. All right. Thank you very much for all the inputs, Arrow, Evelyn, and Shivendra. And thank you all for joining and for sharing your questions and comments in the past minutes. Let's go through these questions and let's start with one which has been asked frequently. So, Evelyn, this one is for you, yeah? The question is, based on the data that was evaluated, are there some chemical groups that we saw were present or detected in most countries? Evelyn, if you can please share your feedback on that.
Yes, Rakesh. Actually, based on our internal study of this wastewater testing data, in the group of APEO, NPEO is the most frequently detected chemical. And if we go back to slide 19, chemical groups detected in different countries, you can see that more than one countries are marked with the color blocks for AP, APEOs, PSCs, phthalates, and heavy metals, which means in these countries we have findings of these chemical groups, either in wastewater or sludge, or even in incoming water also. Although I use the same color for the same chemical group, in general, the detected chemicals can be different. For example, AP were found in both China and the Vietnam reports. Although the findings are from sludge sample, as marked in brown here, the detected types of AP are not the same. In Vietnam reports, it was nanophenol were found, while in reports from China, both NP and OP were detected. Yeah. Thank you.
Okay. Thanks, Evelyn. Let's take then that connection to what is being asked, Arrow. As we saw from the registrations, a lot of participants mentioned that they still have to address the problem with APEOs being detected. What have you observed so far with the root cause analysis audits that you have conducted and what you have observed?
As I
Arrow.
said just now, yeah, can you hear me?
Yes.
Yeah, as I just said during the webinar, I said we should check if the presence of APO is a certain event. So firstly, we should collect reports in the past years and to check if APO is always present in the wastewater, and to check if there is any APO contamination in the incoming water. And then we could check a recipe, SDS, MRSL compliance declaration, chemical testing reports, and so on to narrow down the range of suspected chemicals. As Shivendra has talked just now, APO may come from many sources like emulsification, softener, detergent, and so on. But please don't forget, APO may also come from the raw material like a spring oil. Yeah.
Okay. Thanks a lot, Arrow, for those inputs here. Then we also hear about the question being that, have you come across certain cases where because of chemical detected in finished product based on RSL, input chemistry validation was carried out and replaced? Shivendra, I guess this was the recent cases that you were involved with, right? Would you like to share a little bit?
Yeah, I just want to share my feedback, and based on the different factories sharing their experience with me also, that earlier they are facing a lot of issues for bonding of this hazardous chemical in the wastewater. But afterward, when they are complying with the MRSL requirement and the RSL compliant chemical, which do not have these hazardous chemicals, they see a drastic changes even in the finished product also, and even in the wastewater parameters, where even when we are talking earlier, like Ms. Arrow is stating about APO also. So there are some factories where showing that there is problem of APO is there. So while using this type of chemicals which are compliant with the MRSL, these type of issues are also being solved out due to that.
Okay.
Yeah. Thank you.
Thanks a lot. Thanks, Shivendra. Then, Arrow, we talk about the question is, while the RCA workflow and process is understandable and the guidance, the question is, what have you seen in terms of your experience? How long does it take to conduct an RCA? Yeah? And what is your recommendation?
I think how long did it take to do the RCA? I think it depends. If factory has a good chemical management system and all necessary documents are available, so we only need to spend 1 or 2 days for the on-site document review, and for 1 or 2 days for the on-site plant tour to check if any contamination or other chemical used in the factory, and waiting for the testing reports of most suspected chemicals for around 10 working days. So once the root cause is addressed, so the factory can then start the substitution. But if the factory has a very poor chemical management system and no SDS, no MRSL compliance declaration, so it will be very difficult to start RCA. Or if we continue to do the RCA, the cost for the chemical testing will be very high because we cannot narrow down the range of suspected chemicals. So in this situation, we suggest the factories to collect the documents firstly, but it may take a very long time.
Got it. Thanks, Arrow. Let's connect to this. The next question which is asked is, what would be the cost for an RCA, both for factory in internal and with external resources? Arrow, would you like to talk a little bit about what has to be taken into consideration and what you've seen in terms of time required and cost? Because in some cases, it would be a more expensive chemical, but perhaps in effluent treatment, then they use less energy, yeah? So they might have to look at the big picture, right? Do you want to share some insights there?
I think it depends on the factory size and the factory manufacturing process, and how many chemicals are used in the production and the non-production. So the mandates and the cost will be depend.
Okay, got it. Thanks, Arrow. The next one is specific, I guess, to India. Shivendra, the question is, what do you observe in terms of wastewater analysis or sludge analysis for facilities in India where ZLD is required? Shivendra, do you want to share some feedback on that?
Like when we are talking about ZDLD, the Zero Liquid Discharge Unit, in the last year, after June, this additional information has been added. So basically for ZDLD, when we are talking about, there only the sampling points are raw wastewater and sludge to be tested. And when we are talking about these two parameters, AP chlorophenols detection is there in wastewater, and particularly heavy metals are there in incoming water, wastewater and sludge. So basically when we are talking about the heavy metals, it is one of the common hazardous parameter which are found in lot of different types of chemicals which are used in dyeing, finishing and all that, while we are looking at which particular test to be do as per the MRSL for any particular chemical we receive.
Okay, all right.
Yeah.
Thank you, Shivendra. Yeah. All right. The next one is from our friends in Turkey. The question is that in Turkey, they face problems with heavy metals, and when the chemical inventory list was analyzed, there was no presence of heavy metals in the ingredients. Yeah, is there any recommendation to address this issue? Arrow, I think you came across several such cases, right? You want to share some inputs, please?
Yeah, no problem. Heavy metals, I think it is the problem that manufacturers have encountered in the past. Even in some testing reports, only heavy metals are detected and other parameters are not detected. So heavy metals are usually used in the dyeing stuff to improve the color performance. But we also need to know that there are 12 kinds of heavy metals in total in ZDHC WasteWater scope. So different heavy metals may come from different sources. So we need to analyze case by case. According to my experience, 3 to 5 heavy metals are most often detected in the wastewater, such as chromium, antimony, and magnesium. So as I said just now, that white stuff is the most common source of heavy metals, but there are also many other sources for these heavy metals. For example, chromium may come from wastewater testing chemicals if the factory have the laboratories. So this may be one source. And if a factory have the printing process, and the chromium may also come from the process of making the screen. And antimony, the most common source is the polyester, and it will working as the catalyst during the polyester manufacturing. And magnesium may come from the potassium magnate. It is also used for the testing. So if the factory have the laboratories, it may be one source. And the magnesium may also come from the wastewater treatment chemicals like polymeric ferric sulfide, because the polymeric ferric sulfide is being produced from ores. So magnesium is also present in the ores. So magnesium will exist as contaminants in the polymeric ferric sulfide, and if factories treat the wastewater with the polymeric ferric sulfide, the magnesium will be also along with these chemicals into the wastewater. Yeah, thank you.
Thanks, Arrow. There's a follow-up question with regards to the cost. While we realize that chemical substances are being detected in wastewater, how do you see the cost of replacing with MRSL compliant chemicals? I think so it's clear that in some cases, when you purchase a chemical which is conformant with MRSL or with other chemical regulations, that it could be that the price is higher. So a lot of mature factories, they go ahead by conducting a material flow cost analysis, wherein they look at the input chemicals being used, the amount of those chemicals being used, the amount of water being used in production, the amount of energy being used in production, and then also looking at the amount of energy being used in the effluent treatment plant. So in some cases, which was shown by studies from UNIDO, there were input chemicals which were being used which were not conformant with these standards, and they were cheaper than chemicals with the similar function. However, the factory had to use additional energy and chemicals to treat them in their ETP, and that also is a cost. Yeah. So while you would look at cost for purchasing input chemical, perhaps it would be useful when you look at the ecosystem using material flow cost analysis to see how it will impact your overall resources being used. Then there's another question with regards to can we do a link between REACH and ZDHC MRSL? Yes, of course, absolutely. Whether we talk of MRSL and the requirements in wastewater or also in chemical products, you would see by the literature review that it was based on scientific evidence linked to chemicals which were already in scope of REACH, SVHCs and so on, and looking at the practicality of having those substances replaced from input chemistry if the industry is ready, if it's possible at affordable cost. So yes, and this is why, just like REACH, SVHC, it's a living system. It changes every few months. In the same way, ZDHC MRSL would also be updating at least every 2 years, yeah. And there's a system that ZDHC has set up where you can recommend additional chemical substances which should be in scope and how they should be addressed, yeah. So yes, it's a living system. All right, then I think we covered most of the questions. I want to thank you all for participating, for actively asking questions, for the specific questions you have with regards to test reports and your specific factory example. We will reach out to you via email, yeah, rather than using today's forum. Thank you all for listening. Please stay safe. Take care. Thank you. Bye.